Today we shall see what is actually we will see little more closer into the nature of gases and some of its properties. Okay. See, what is actually the gas pressure? Probably if you see this cylinder, cooking gas cylinder, outside of that cylinder they will be writing it's say maybe 5 atm, sometimes 5 atm, I don't know, maybe different units they will do. Actually, maybe 5 atm, maybe 10 atm or like 5 kilopascal. Some unit they will write actually. See, this is actually nothing but the pressure what is kept in the gas. Okay. So now what I am trying to say is, okay. See, actually when you blow up a balloon, okay. See, this is this balloon. It will start keep on hitting on the surface of these particles. Actually, the gas particles. Okay. That will keep on actually as you know it is keep on moving, right? Okay, it will move from here and move from here, so move from here. So this balloon, it will start hitting on the surface of these particles, it will keep on hitting on the surface of balloon, right? So obviously when it hit, right, if anything hits, actually if I hit on this surface also, there will be some pressure acting on this board. Obviously in the same way, okay. So, when we are when this particles actually it is hitting, that time also, this, obviously these particles, it will be exerting some pressure on the surface of below. Okay, and now let's see what factors will be contributing to the pressure. Uh, Different gases, it will exert a different pressure. Some gases, like it will be moving very fast. Lighter gases, for example, say hydrogen, helium, and those gases, it will exert more pressure. But the heavier gas, due to its mass is heavy, it will not move that fast. Obviously, the pressure it is exerting, it will be less. Okay, and let's see actually what are the two contributing factors which will be contributing to the pressure of the gas. Okay. So first one is temperature. See, I will tell you. If I see this, so this is again some gas. What will happen? No? So let it be this gas if I am keeping it 10 degrees Celsius, and here I started boiling this. So these gases, it will keep on exerting some pressure on here. So what is actually the happening is, see, because since at 10 degrees Celsius it will be moving very slow, right? So it will be moving slow. So the force in which it is exerting pressure, it will be less. But on the other hand, when you start to boil it, when you start to heat it, okay. So what will happen now? Actually, this due to the heat energy, these things, I mean like this particle, it will acquire more energy. It will keep on acquiring more energy, and it will acquire more energy, and the movement will be very fast. Movement, it will be very pretty good. So what shall it will happen is actually these gas particles, it will keep on hitting. It will start hitting the surface of balloon even at higher forces. Okay. So even at a very higher forces, if these particles, it will start to hit. Obviously, what will happen? Since the pressure it is exerting, it is more. Okay. So yeah, since the pressure it is exerting is more in this. Okay, let it be. We heated up to 75 degrees Celsius. So okay. So here actually it started hit this particle. It started hit on the surface of a balloon little in a lower rate. On the other hand, here the particle, it will hit very fast, very strongly it will hit. So ultimately, like the you know ultimately actually the here the pressure it will be high. Maybe suppose if here it is 1 atmospheric pressure, here it will be 5 atmospheric pressure it will come. Okay. So the temperature it got a definite role in the case of gaseous pressure. For example, you see this cooking this one pressure cooker. Pressure cooker, like when we are heating. Okay. See the pressure cooker. Okay, let it be like this. So this is you are heating. There is a whistle right above or on the surface or on above the pressure cooker. So what will happen if without heating, if you are keeping, what will happen? Actually, okay, there is enough amount of water or whatever, maybe like maybe you are keeping some rice for boiling. Okay, so without heating, what will happen? Actually, you don't find that this whistling it will be whistling sound. It is not coming right. So, but when you are heating, what will happen is, sorry for the whistle, when you are heating, what will happen is actually this water, mostly water, it will evaporates and it will generate more gases. Okay, water gases, so H2O gas. So, this it will keep on heating on the surface of pressure cooker. Obviously, it want to somehow come out of this. So that is the purpose of this whistle. Obviously, when the whistle open, okay, this water vapor it will go out. Okay, so this is the case actually. Atmospheric pressure it got a the pressure it got a definite role in the case of temperature. Sorry, gaseous pressure it got a definite role with the temperature. Okay. Okay. So now, what are the other contributing factors actually other than this temperature? So another contributing factor is pressure. Pressure also got some definite role in the case of gas pressure. For instance, I will tell you. See, this one, right? Actually, this cycle pump. We will be pumping. We will be pumping to fill this cycle, right? Okay. So even the cycle pump, no. See, what is actually, you know very well, right? Actually, when we are pumping, we will accept only less pressure. When we are pumping closer to the piston is moving closer, we will be applying more pressure, right? Why? Because the pressure, the gas which is present in that pump piston, it is confined into lesser space. Obviously, we may need to apply more pressure. We may need to apply more force into that. So, actually, here, okay, I will write the structure of a gas cycle pump. Okay. So here, okay, the particles are here. So I apply pressure. What will happen now? All of these gas particles, okay, it reached here. Okay, I started applying pressure. So it will, okay, these gas particles, it will get confined in a lower space. Okay, so the frequency in which, the number of heating in which, number of collisions in which these gas particles, it is hitting on the surface of this piston, it is going to be very high. Okay, it's going to be very high. So what is going to happen is actually here more number of collisions actually, because the particles are confined, gas particles are confined in a lesser volume. So more collisions it will happen. Actually here if it is say suppose here let it be 30 particles are in 1 centimeter square, not let it be or not 1 centimeter square, okay, 1 meter square. Here actually these 30 particles are in 0.5 meter square. So more particles confined in a lesser volume, obviously there will be more collisions. So I have more, very huge number of collisions it will be there. Okay, so this is going to happen. Now, what is the thing is, what the thing is actually, pressure also got a definite role. Like see, the example in which I told you is a cycle pump. So the two things actually, two parameters. One is temperature. Next one is pressure. So gas pressure is proportional to, when you increase the temperature, gas pressure increases. When you apply more pressure also, gas pressure increases. Okay, both have a positive impact on gas pressure. Okay.